There is only one place in the universe that generates that much gravity, and it's inside the largest stars. When massive stars, 10 times heavier than our sun, die, gravity crushes them, creating a huge explosion, a supernova. But some stars are even bigger than that. These supermassive stars weigh 100 times more than our sun and have 100 times more gravity. When one of these stars dies, it sets off the biggest explosion in the universe, a hypernova. This is the birth of a black hole. Our universe is full of stars. At the end of their lives, some die quietly. Others go out in spectacular explosions. And some give birth to black holes.
If you have a star, a supermassive star that's 100 times the mass of the sun, at the end of its life, the core runs out of fuel. There's nothing left to hold it up, and the core collapses down into a black hole.
When that happens, the enormous gravity generated at the heart of supermassive stars runs wild. This is the dying star, VY Canis Majoris. It's more than 1 billion miles across. Like all stars, it's a giant nuclear fusion reactor, pumping energy outward. At the same time, the star's extreme gravity crushes inward. For a few million years, fusion and gravity are locked in standoff. But when the star runs out of fuel, fusion stops, and the stalemate ends. Gravity wins. In a millisecond, the core shrinks to a fraction of its original size, and a baby black hole is born. Immediately, it starts to cannibalize what's left of the star.
As matter swirls into the black hole, it gets incredibly hot, and there are magnetic forces and frictional forces, and it's just a witch's brew, a nightmare what's going on right above the surface of the black hole.
The new black hole in the middle keeps feeding on the body of the star around it. It eats the gas so fast, it chokes and coughs, blasting out huge beams of energy.
They basically eat their way out from the star. This happens in milliseconds. It happens before the rest of the star even knows the core is gone. And so basically, this star is dead before it hits the ground.
Finally, the star explodes. In 1 second, it blasts out 100 times more energy than our sun will produce over its entire life. What's left is a new black hole and 2 jets of energy hurtling through the universe at the speed of light. These jets are called gamma-ray bursts.
They're incredibly energetic events. In terms of raw energy and power, gamma-ray bursts are second only to the Big Bang itself.
Most of them last only a few seconds, and they fry anything in their way.
They're so intense that if there was a gamma-ray burster in the region of our galaxy near our solar system, it could literally vaporize the entire planet.
Fortunately, most gamma-ray bursts occur outside our galaxy. But they tell us something important about black holes and how our universe works.
What we were seeing every time a gamma ray burst went off was basically the birth cry of a black hole.
By counting gamma ray bursts, astronomers can figure out how many black holes are being created. In 2004, NASA launched the SWIFT probe to scan the universe for gamma ray bursts.
5, 4, 3, 2, 1. We have ignition, and we have liftoff of NASA's SWIFT spacecraft on a mission to study and understand gamma ray bursts throughout the universe.
This is the most powerful gamma ray burst SWIFT has detected so far. The flash of light announces the birth of a new black hole on the other side of the universe. SWIFT can only look at a fraction of what's out there. Still, it detects at least one gamma ray burst every day. That discovery rocked astronomy to its foundations.
We once thought that black holes like unicorns could never be found. We now believe that there are perhaps billions of black holes in the night sky.